Let's look at an interpretation of the confidence interval. In this case, a proportion of teens in Florida are considered regular smokers. The definition will be created by the researchers. What that means, a random sample of 980. Florida's teens showed 134 considered themselves regular smokers by the stated definition. The 95% confidence interval is created with the data producing a margin of error of plus or minus 0.0215, which is the following is the correct interpretation of the 95% confidence interval. It's really quick. We have p hat here is 134 over 980. Then if I take that amount and subtract plus and minus this margin of error, I'm going to assume that this is the result. As a matter of fact, I'm going to assume that this is the result here. I'm not going to calculate it. So 134 over 980 is the 0.1367. You see right there. And when I do the confidence interval, I get this two numbers. Okay. So let's look at these. About 95% of the time, a sample will produce a value that will fall in the interval between these two values. And that is definitely false. That's not true. About 95% of the time, it's a sample. I'm guessing a sample means the result of a statistic. But a point estimate falls between these two values, and that is definitely false because it's not about 95% of the time. It's really 100% of the time. That's going to happen because the statistic is the center of this interval. So that's definitely false. We are 90% certain that 13.67% of teens in Florida are regular smokers, and that is, again, false. The 95% confidence level has to do with the interval. The interval containing the parameter. But it's not about the chance that I'm assuming this is our point estimate, is true. As a matter of fact, I'm almost nearly 99.999% sure that this number is not correct. There's a 95% confidence in the true proportion regular smoking teen in Florida being in the interval blah blah blah. Okay, that sounds better. There's a 90% confidence in the true proportion of regular smoking teens being in the interval, and that's actually correct. That's pretty much what it says. It's all about how confident we are that in this interval we've just created, the true proportion happens to be in there. That's correct. What about this one? 95% of the time, the true proportion of teen smokers will be found in this interval, false. The way this is stated, it feels like 95% of the time, the true proportion of teen smokers will be found in the interval number one. So this makes it seem as if this is varying the true proportion, which is not true. And it's bouncing around while these two numbers are fixed. And it's the other way around. This is fixed. And these two numbers are bouncing around. So these numbers are not going to be the same every single time. So this step is absolutely false. That doesn't happen 95% of the time. No, that this will be falling into that interval. Absolutely not. There's a 95% chance that our sample proportion, 13.6%, will fall in the created interval. And again, this is similar to A, same thing as A, false. There's not a 90% chance, there's a 100% chance, as that is the center. This is the center of the created interval. So it's got to be always 100% in that interval. So the only statement that is correct is C here. But number 22, a random sample of 1,034 Americans were asked if they support our alliance in NATO. Of the sample, 80% said we should continue our alliance with NATO. So this is really p hat here. And 90% confidence interval was created with data producing a margin of error plus or minus 0.0224. Again, which of the following is the correct interpretation of the 95% confidence interval? Again, I'm assuming that the 0.8 plus or minus 0.0244 produces this interval right here. I am 95% confident that the true proportion of Americans that support NATO alliance is between blah and blah. Yeah, that seems correct. I'm going to read it one more time. I'm 90% confident, so again, it's a personal probability. The true proportion of Americans, again, what I'm trying to estimate, will support NATO is between blah and blah. Yeah, I think so. That seems correct. There's a 95% probability that the proportion 80% is in the created interval. Again, this is false. Again, same as before. There's a 90% probability. No, there's a 100% probability that our point estimate will fall in the created interval. The proportion of Americans that support NATO is between 0.76 and 0.82. I'm going to say this is false. And what's missing here? So it seems like it's right, but the proportion of Americans, that's okay. That's what we estimate. That is actually partly correct. Missing is confidence level mentioned. So you must state these with a level of confidence. And that's what I'm choosing here. When 95% confidence interval was created, so I'm 95% confident. I mean, would you do like create 95% confidence interval, but yet you're 90% confident? That would be odd. Again, the reason you're 95% confident is because you're doing a procedure that 95% of the time will contain the true proportion. Let's put this question here. A person decides to create a 99% confidence interval. The meaning of the chosen probability in a confidence interval is that, check all that is true, it measures the chance our statistic is within a certain number of standard deviations from the true parameter. Okay, the 99% confidence, again, in level. So we already established that this is completely unknown to us. And what is it, 99% or whatever it is? It measures the chance our statistic, so p hat, is within a certain number of standard deviations away from the true parameter. And the answer is, yeah, that's true. That's what this does. So this is unknown. The 9% confidence just means that I'm capturing a certain percentage containing a certain area around this unknown value. And that's true. This will have whatever this number is, however many moves move away, this has exactly that chance of falling within that within a certain number of standard deviations, meaning whatever is attached to 99%. So 90%, it's the number of standard deviations is 2.576. It measures, so that's just true. It measures the probability that the process of creating a confidence interval, the process of creating a confidence interval will create an interval, okay, a specific interval containing the parameter in the long run. Again, notice I'm not mentioning what that interval is, just, and notice all this is in the future. It doesn't have anything in specific now. It measures the probability, and there's a probability. Probability is also in the future. And all this is mentioned here is in the future. That the process of creating a confidence interval, yeah, something that will happen in the future, will create an interval in the future containing the parameter in the long run. In the future, all this is in the future. So if that's the case, yeah, that's true. That's what this thing does. It creates, again, a situation, even though I don't know what this is. But as soon as you create a certain confidence level, all it does is create, again, some type of interval around this value. And in the long run, these values will fall inside that interval. So this is also true.